Atomic spectrum. Line spectrum. The atomic spectrum is a fascinating concept in physical chemistry. Imagine you're looking at light emitted by elements when they're heated or turned into a gas. When this light passes through a spectrometer, which is a device used to analyze light, it reveals something remarkable. Instead of a continuous range of colors, you see distinct lines with dark spaces in between. These lines are like a unique fingerprint for each element, telling us about its identity and properties. Let's take sodium as an example. When sodium is heated, its emitted light shows two distinct yellow lines separated by a specific distance in the spectrum. Hydrogen, on the other hand, displays numerous lines of different colors, each at varying distances from one another. As the wavelength of hydrogen's lines decreases, they get closer together until they form a continuous spectrum beyond a certain point. Now, this atomic spectrum can be seen in two different ways. 1. Atomic emission spectrum *. Imagine heating up elements until they emit light. The spectrum of this emitted light shows bright lines against a dark background. This is what's known as the atomic emission spectrum. 2. Atomic absorption spectrum *. Instead of heating elements, picture passing white light through a gaseous sample of an element. Here, the element absorbs specific wavelengths of light while allowing the rest to pass through. The absorbed wavelengths show up as dark lines against a bright background in the spectrum, termed the atomic absorption spectrum. What's truly fascinating is that the positions and wavelengths of these lines in both emission and absorption spectra match exactly. They appear bright in emission because the element is emitting those wavelengths, and they appear dark in absorption because the element is absorbing those wavelengths. This phenomenon is a fundamental principle in understanding the behavior of light and matter at the atomic level.